through some word problems of combinations. First one, how many chords can be drawn through 21 points on a circle? From 21 points on a circle, and we know that a chord needs 2 points, right? So here from 21 different points taken 2 at a time. So we will do the combination, okay? So here number of chords is equal to number of chords is equal to from 21 point, okay, selecting 2 at a time, okay. So 21 C2, that is 21 factorial divided by 21 minus 2 factorial. So what is NCR? N factorial. See, NCR is nothing but n factorial divided by n minus r factorial into r factorial, okay. The number of combinations of n different objects taken r at a time is n factorial divided by n minus r factorial into r factorial. So here 21 C2, so 21 factorial divided by 21 minus 2 factorial into 2 factorial. That is 21 factorial divided by, here it is nothing but 19 factorial into 2 factorial. So how can we find? 21 into 20 into 19 factorial, isn't it? See, 21 factorial can be written as 21 into 20 into 19 factorial divided by 19 factorial into 2 factorial, okay. So 19 factorial cancelled. So 2 factorial is nothing but 2, okay. So it will be 10. So 21 into, here 2 ones are 2, 10, okay. So 21 into 10, that is 210. So we can draw 210 chords on a circle for 21 points, okay. Next question is, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? See here, see it is given separately, okay. See here we have to select 3 boys and 3 girls. 3 boys out of 5 boys, okay, and 3 girls out of 4 girls, okay. Total we have to select 6 people, right? So 6 people from out of 9 people, okay. But here it is given separately, okay. We have to select 3 boys from out of 5 boys, okay, and 3 girls out of 4 girls. So the number of ways of selection, here order is not important, okay. So we will do the combination. So number of ways of selection, number of ways of selection is equal to, okay, here 3 boys, okay, 3 boys out of 5 boys. So 5C3, okay, into, and because here we have to select 6 people, okay, we have to select total 6 people, and it is given separately 3 boys and 3 girls, okay. So 5C3, that is 3 boys out of 5 boys, and, okay, and into 4C3, okay, 3 girls out of 4 girls, okay. So it is the answer. Now let us find it. 5C3, that is nothing but 5 factorial divided by 5 minus 3 factorial into 3 factorial into 4 factorial divided by 4 minus 3 factorial into 3 factorial, okay. So here 5 factorial divided by 2 factorial into 3 factorial into 4 factorial divided by 4 minus 3, that is 1 factorial. 1 factorial is nothing but 1 itself. So 3 factorial, okay. So again here we can see cancel 3 factorial, we can cancel because we know that 5 factorial is nothing but 5 into 4 into 3 factorial. So 3 factorial will be cancelled. So remaining 5 into 4 divided by 2 factorial is nothing but 2 itself, okay, into, here also 3 factorial will cancel, so remaining 4 in numerator, so 4, okay. Now here 2 ones are 2 2s are, then 5 4s are 20, 20 2s are 40, okay. So 40 is the answer. 2 ones are 2 twos are 40 is the answer. Okay. So what is the number of ways of selection? 40. Next question. Find the number of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. Okay. See, it is also same as previous question. See, here also it is given separately, right? Means, see, it is mentioned 3 balls of each color. Okay. Actually, totally we have to select 9 balls. Okay. 9 balls and 3 balls of each color. That means 3 red balls, 3 white balls, 3 blue balls. So, we have to select 3 red balls out of 6 red balls. Okay. And 3 white balls out of 5 white balls. Okay. And 3 blue balls out of 5 blue balls. Okay. So here also order is not important. Order does not matter. So the problem is of combination. So what is the way of selecting? Number of way of selecting is equal to, here itself I will write. Okay. So here first we will select 3 balls. Okay, 3 red balls out of 6 red balls. Okay. So total we have to select 9 balls. Okay. So 6 C 3 into, okay, because we have to select 9 balls. So 3 3 3. It is mentioned 3 balls of each color. So 3 red, 3 white and 3 blue. Okay. So out of 6 red balls we will select 3 red balls. Okay, into, next out of 5 white balls we will select 3 white balls, into, out of 5 blue balls we will select 3 blue balls. Okay. So the combination is 6C3 into 5C3 into 5C3. Okay. Next, let us find 6 factorial divided by 6 minus 3 factorial, 3 factorial into 3 factorial. Okay, into 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial. Okay, see, our formula is NCR is equal to n factorial divided by n minus r factorial into r factorial. Okay, keep it in your mind. NCR is equal to n factorial divided by n minus r factorial into r factorial. Okay, so into, here 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial. So here up to 3 factorial it will cancel. So it will be 6 into 5 into 4 divided by 3 factorial is nothing but 3 into 2 into 1, right? So 3 into 2 is 6. 6 into 1, 6 itself. So 6 into, here 3 factorial cancelled. So 5 into 4 divided by 2 factorial is nothing but 2 itself, into 5 factorial, 3 factorial cancelled. So 4 into 5, okay, divided by 2 factorial is 2. Okay. Next, here 6 cancelled, then 20 into 2 ones are 2 twos are, so 10 into, here also 2 ones are 2 twos are, into 10, that is 2000. So the number of ways of selecting is 2000. In 2000 ways we can select 3 red balls, 3 white balls and 3 blue balls out of these balls. Okay. Fourth question, determine the number of 5 card combinations out of deck of 52 cards if there is exactly one ace in each combination. Okay, so here see out of 52 cards we have to select 5 cards. Okay, next one more thing, see it is mentioned there is exactly one ace. Okay, so for each selection one ace should be there. Okay, and remaining 4 cards any other cards. Okay, that is not mentioned. So, but here exactly one ace should be there for each selection. Okay, so here first we should know how many ace cards are there. Out of 52 cards, how many ace cards are there? We know that there are 4 ace cards. Okay, so we have to select one ace card out of 4 cards. Okay, and remaining 42 other cards. Okay, 42 other cards. So out of 42 cards, we have to select 4 cards. Okay, we have to select total 5 cards. Okay, out of 52 cards. But here it is mentioned there is exactly one ace should be there. Okay, so there is exactly one ace in each combination. That is, for each selection, one ace should be there. So there are 4 ace out of 52 cards. Okay, and 48 other cards. Okay, so here the number of number of ways of selection is equal to, say, for each selection one ace card should be there, right? So out of 4 cards we will select one ace card. Okay, so 4C1 into, and remaining 4 cards, any other cards. Okay, remaining 4 cards we will select out of 48 cards. Okay, that is 52 minus 4. Okay, 4 cards are ace cards and remaining 48 cards are other cards. Okay, so out of 48 other cards we will select 4 cards. Okay, so 4C1 into 48C4. Okay, that is 4C1, 4 factorial divided by 4 minus 1, that is 3 factorial into 1 factorial, into here 48 factorial divided by 48 minus 4, 44 factorial into 4 factorial. Okay, here it is 1 factorial is 1 itself, 3 factorial cancelled, so 4 remaining, and into here 44 cancelled, so remaining 48 into 47 into 46 into 45. Okay, so 44 factorial cancelled divided by 4 factorial, 4 into 3 into 2 into 1. Okay, so this 4 cancelled. Again next 3 ones are 315. Okay, next 2 ones are 224. So remaining 24 into 47 into 46 into 15. So the answer is 77, 83, 20. Okay, that is 7,78,320 is the number of ways of selection. Next question is, in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? Okay, so here as we know, we have to select 11 people. Okay, 11 players out of 17 players. Okay, there are total 17 players. Okay, including bowlers. Okay, so there are total 17 players. We have to select 7 players. Okay, that is common. Here it is mentioned that for each selection 4 bowlers must be there. Okay, for each selection 4 bowlers must be there. Okay, so total how many bowlers are there? Total 5 bowlers, right? So here see, only 5 players can bowl. Okay, so here total 5 bowlers. So we have to select 4 bowlers out of 5 bowlers, right? So here, so what is the number of a selection? Number of ways of selection. Number of ways of selection is equal to, okay, here total 17 players. Out of 17 we have to select 11 players, and it is mentioned that for each selection 4 bowlers should be there. Okay, so 4 bowlers and 7 other players. Okay, so here out of 5 bowlers we will select 4 bowlers. Okay, and remaining 12 players. Okay, so out of 12 other players, okay, out of 12 players we will select 11 minus 4, that is 7. Okay, so 7 players. So here first we will select out of 5 4 bowlers. Okay, into remaining 17 minus 5 12. Okay, 12 players. So out of 12 players we will select, total we have to select 7 players, right? So 4 selected, next 11 minus 4, that is 7. Okay, so 5C4 into 12C4, 12C7. Okay, why? Because we have to select 4. See, it is mentioned, it must include exactly 4 bowlers. Okay, so for each selection 4 bowlers must be there. Okay, therefore total 11 people, 11 players we have to select. So 11 minus 4, that is 7. So out of 12 players, okay, out of 12 players we have to select 7 players. Okay, and out of 5 bowlers we have to select 4 bowlers, right? So here 5 factorial divided by 5 minus 4, 1 factorial. 1 factorial is 1 itself, so divided by 4 factorial into 12 factorial divided by 12 minus 7, 5 factorial into 7 factorial. Okay, so that is equal to, here 4 factorial cancelled, remaining only 5 into 12 factorial, till 7 factorial it is cancelled. So 12 into 11 into 10 into 9 into 8, okay, 7 factorial cancelled, divided by 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. So 5 cancelled, next 4 ones are 4 threes are 3 cancelled, next 2 ones are 2 fives are, okay, then remaining 11 into 5 into 9 into 8, okay, that is 55 into 72, that is equal to 2 fives are 10, 2 fives are 10, 11, 7 fives are 35, 3, 7 fives are 35, 38, that is 0, 6, 9, 3, okay, 3960. So number of ways of selection is 3960. Next question is, a box contains 5 red balls and 6 black balls. In how many ways 6 balls be selected so that there are at least 2 balls of each color? So read it once again. A box contains 5 red balls and 6 black balls. In how many ways 6 balls be selected? See, if the question is still here, we can write directly, right? So here total there are 11 balls. 5 red balls and 6 black balls. So out of 11 balls we have to select 6 balls. So the combination is 11C6. Okay, to be confused, see one more thing, it is mentioned that so that there are at least 2 balls of each color. That means for each selection at least 2 balls should be there. At least means the possible cases 2 red balls, 4 black balls. Total we have to 6 balls. Okay, we have to select 6 balls. So if we select 2 red balls, then 4 black balls. 3 red balls, 3 black balls. Okay, 4 red balls, 2 black balls. Okay, so that in 3 cases we have to select. Okay, 3 combinations will be there. So here first number of ways of combination, number of ways of selection. Is equal to, see first at least 2, okay, not exactly 2. See, if you don't understand the question, read it once again. Okay, so at least 2 balls. So at least 2 balls. So here 3 is also possible. Okay, 2, 3, 4, 5 is also possible, but here it is mentioned at least 2 balls of each color and 6 balls we have to select, total 6. If we select 1 5 balls, okay, then another one will be 1 ball, right? 5 plus 1. So it is not possible because here it is mentioned at least 2 balls of each color. Okay. So here see, first we will select out of 5 balls, 2 red balls. Okay. Out of 5 red balls, 2 red balls we will select. Then we have to select a total 6 balls. So into, out of 6 balls we will select 4 black balls. Okay. So now total 6 plus, okay, plus next combination. Okay. That is, we will, if we select 3 balls, so 5C3, if we select 3 red balls, then 6C3. Okay. Then we have to select 3 black balls out of 6 black balls. One more combination. Next, see, we can select 5 red balls. Okay, because at least 2. Okay, that is greater than or equal to 2. So 5C4 into 6C2, right? If we select 4 red balls, then we have to select 2 black balls. Okay, because the total we have to select 6 balls. Okay, then plus, see, let us see here, if we write 5C5, that is possible because at least 2 balls. Okay, if we select 5 red balls, okay, if we select 5 red balls, we will have to select 1 black ball, right? So it is not possible according to this. It is given that at least 2 balls of each color. Okay, so each color at least 2 balls should be there for each selection. So it is not possible. Okay, so only 3 combinations. Okay, so here let us add. See, what is the number of ways of selection? Find 5 factorial divided by, no space, so I will write it here. So 5 plus, okay, 5C4 into 6C2. Okay, then 5 factorial divided by 5 minus 2, 3 factorial into 2 factorial into 6 factorial divided by 6 minus 4, 2 factorial into 4 factorial plus 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial into 6 factorial divided by 6 minus 3 is 3 factorial into 3 factorial plus 5 factorial divided by 5 minus 2 is 5 minus 4 is 1 factorial is 1 itself. So next into 4 factorial into 6 factorial divided by 6 minus 2 is 4 factorial into 2 factorial. Okay, then here 5 factorial, 3 factorial cancelled. So remaining 5 into 4 divided by 2 factorial is 2 itself. Okay, into 6 factorial, 4 factorial cancelled. So remaining 6 into 5 divided by 2 factorial is 2 plus 5 factorial, 3 factorial cancelled. Remaining 5 into 4 divided by 2 into here 6 factorial, 3 factorial cancelled. So remaining here 6 into 5 into 4 divided by 3 factorial is nothing but 3 into 2 into 1, that is 6, right? 6 plus here 5 factorial, sorry, we can cancel 4 factorial. So remaining 5 into 6 factorial, 4 factorial cancelled. So numerator 6 into 5 divided by 2. Okay. So here 2 1s are 2 2s are 2 1s are 2 3s are. So it is 10 into 15 plus here 5 into 4, 2 1s are 2 2s are. So it is 10 into 6 6 cancelled, 5 4s are 20 plus here 2 1s are 2 3s are. Okay. So 5 3s are 15, 15 5s are 75. So the answer is 150 plus 200 plus 75. 150, that is 350. 350 plus 75 is 425. So the number of ways of selection is 425. Next question is, there are 10 points in a plane of which 4 are collinear. How many different straight lines can be drawn by joining these points? There are 10 points in a plane of which 4 are collinear. Okay, see, suppose it is not given. So what is the answer? Directly we can write. See, there are 10 points and we know that 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we know that we need 2 points for a straight line, right? So there are 10 points. Out of 10 points, we will select 2 points. So 10C2 is the answer. Okay, but here it is mentioned of which 4 are collinear. Okay, 4 are collinear points. Collinear points means the points lying on the same straight line. Okay, points lying on the same straight line or points lying on the single line. Okay, but here see how to find the number of ways of straight lines. See here, first what to do is, first we will find the number of ways of different straight lines out of 10 points, taking 2 at a time. We know that for a straight line we need 2 points, right? So 10C2, okay, 10C2. And see here, since these 4 points are collinear, we can make only one straight line here, isn't it? So what to do? We will subtract. See how many ways we can select from 4 points. That is 4C2. Out of 4 points, taking 2 at a time. Okay, that we will subtract from these total lines, right? And plus this straight line 1. Okay, total 10C2 minus 4C2. Why subtracting 4C2? Why? Because we can make only one straight line from these collinear points. Okay, collinear points means the points lie on the same straight line or single line. Okay, so here, so subtracting 4C2 from these total straight lines. Okay, 10C2 means total straight lines. Okay, number of ways of selecting total straight lines out of 10 points, taking 2 at a time. Okay, so subtracting this 4C2 and plus this line. Okay, collinear points line. Okay, that is plus 1. So it is the answer. Okay, number of ways of selection. Number of ways of selection is equal to, okay, there are total 10 points. So we will find 10C2, okay, combination out of 10 points to selecting 2 points. So that is total number of straight lines. Okay, but here total number of ways of selecting straight lines. Okay, and here since these 4 points are collinear, we can make only one straight line, right? So we will subtract those 4C2. So how many straight lines we can make from 4 points? What is the ways of selection from 4 points out of 2 points? Okay, so that is we have to subtract from this total. Okay, plus and that one straight line. Okay, collinear points, this straight line. We can make only one straight line, right, from these collinear points. So that straight line plus 1. Okay, that is equal to 10 into 10 factorial. Okay, 10 factorial divided by 10 minus 2, that is 8 factorial into 2 factorial minus 4 factorial divided by 2 factorial into 2 factorial plus 1. That is equal to 8 factorial cancelled. So 10 into 9 divided by 2 factorial is 2 minus 2 factorial cancelled. So 3 into 4 divided by 2 plus 1. Okay, here 2 into 2 5s are, so 45 minus here 2 1s are, 2 2s are, minus 6 plus 1. That is 45 minus 6, 39. Okay, plus 1, that is 40. So we can make total 40 lines. Okay, we can make 40 straight lines out of 10 points in which 4 are collinear. Okay.